Hello, today we are going to see how to convert regular expression to the DFA. So, as we know that regular expression and the finite automata are equivalent in their descriptive power. Any regular expression can be converted into finite automata that recognizes the language it describes and vice versa. Okay, as if I have finite automata, I can get the regular expression. If I have a regular expression, I can get the finite automata. So we'll see how to do that. The language is regular if and only if some regular expression can describe it. Uh, Based on what theorem you are saying that there exists one theorem, if a language described by a regular expression, then the language is regular. And for that, supporting lemma says that if a language is irregular, then that can be described by the regular expression. We will see the theorem. Based on the theorem, we will see how to convert the regular expression to the DFA. Let's say there are convert how to convert regular expression into NFA first, and we consider the 6 cases in the formal definition of the regular expression. R is equal to A for some A in the alphabet set. That means my regular expression contains a single alphabet A. Then language of that regular expression is a set of element containing only one element, that is A. Then NFA can be recognized, or we can draw the NFA that recognizes the same language L of R with the help of this figure. Start, accept. Once you read A, just accept it. This is way to write the NFA for language containing A as element. If my regular expression is epsilon, then DFA we can write like this. Start state and the end state will be the same state. If my language generated by the regular expression is a phi, then DFA can be drawn like this. Just a state which doesn't which doesn't accept anything. Okay, that's why it is phi. Now, closure properties. My regular expression is R. Then closure of that is again a regular expression. But how to show it in the NFA form? Uh, this language accepts 0 or more occurrences. Fine. So start state should be the end state. Remember that because we are saying the epsilon closure. So once you start, then epsilon is concatenated with A. Okay, this will give me the single A. But what if I wanted to ask any number of A's? We need to look back, which will give me the A on the, or I can say multiple A's, 0 or more occurrences of A. Now, R1 concatenate with the R2. If uh, A is from the R1 and B is from the R2, then how to do the AB string, or how to get the AB input? For language AB, how to draw the NFA? We will start, and on epsilon we have first we will take A. It is concatenated with the epsilon and again concatenated with the B. This is way to draw the concatenation. Remember that in concatenation, order matters. Union, there are multiple ways. Fine. So let's take one example of union. A union B. How to do that? We will start at A. I say either A or B. So first we will move on the epsilon to the different two paths. Once I read A, I will accept it. And other way, I may accept a B. In that language, it contains both A or B. Now take one more example. A, A, B union A. So what we have done here, first of all, what we are focusing on, concatenation of AB. We want single A will union of that, and we'll take the parenthesis. Fine, this is the sequence. So you how to achieve this? First, you should know how to get the A. Already we have seen single A, how to get the single A, how to get the single B. Now what we want, A concatenation B. Already we have seen AB will be like this. A concatenate with epsilon, then concatenate with the B. Right? Now what we have to do? This and this is union. Okay? They are connected with the help of epsilon added with the new string. So next move will be like this. They are first part is for the AB, next part is for the A. But we are putting the star over here. So we have to consider that star again. Language accept the on the epsilon only we should accept the string. So we need to create another string. Start state will be the end state. We have to add one more state it here on the epsilon. This will accept the epsilon, but we have to make it in the loop. So we have to go back in the both way. So we'll see in the next slide what we have done. Understand here epsilon this part we already covered. Only what we have done before that, this state should be start state, but instead of that what we have done, we added a new state, make it as a starting state and the final state as well on the epsilon. And this AB part we will going back for the loop and only A, so we are going back. I hope you understood this part. Take one more example. A union B star ABA. So single A will give this, single B is this. A union B will be like this. Okay, on A I will go here, on B I will go here. Separate parts are there, but in concatenation we have a single path, one after the other, order matters. Now we want star of that. So what we are supposed to do? We have to introduce one more state here. So what we have done, introduce that state which we make it as a final state because of this star on the epsilon, right? And this part either A or B should be repeated any number of times, so we have to go back. This is newly added. Now whole this complete part we have to add along with the ABA. So for ABA we need to draw that. A concatenated with the epsilon, on B concatenated with the epsilon, and it is again concatenated with the A. Just straightforward. Concatenation is very easy. Fine. Now previous diagram, where this is what our previous diagram. Okay, but only change is that these were the final state. We are not going to make them as final now because we are going to connect it with the this order matter. We are doing the concatenation. So first this part and then ABA we are supposed to concatenate. So instead of making them final here, we are making them non-final. See here, these are now non-final states. We are connecting with the concatenation part, means this string. Okay, we are writing it here, and then it is added or it is connected with the help of epsilon. Okay, and from the starter, so we have to add because this is a star, it may be absent, so we should consider that part as well. If it is nothing is there, we will follow the epsilon, then ABA concatenation, and we will accept the string. I hope you understand this part. For today's lecture, I have referred Michael Sipser's Introduction to the Theory of Computation. Thank you.